Hello everyone, this is your teacher Justina, and if you are still new to my channel, do not forget to subscribe, like, and share for more video notifications. For our video today, we will be having multiplication of polynomials. But before that, let us have this question. What law of exponents do we need to apply in multiplying polynomials? So let us have the needed law of exponents. We have the first one there is to apply the power of product. So the power of product says that we need to uh, add their exponents if they have common bases. So we have the common base x, we just simply copy and then we add the exponents. Then the other law of exponents which is needed in finding the product is the power of a power. So as you have seen, if a power raised to another power, so we just simply copy the base and we multiply the exponents. Then the third law which is needed also is the product of powers. So as you have seen, this is already composed of more than one base, no? As what we have in this law, we have only one base, and this time we have already two bases, and for that we simply distribute the outer exponents to the inner exponents. So we simply multiply the inner and the outer exponents. So let us now find the product of the following polynomials. Let us start with monomial with another monomial. So as you have seen, a monomial 3m will be multiplied to the monomial negative 4cm cubed. And then for this, since we are talking about product, we simply multiply if they have constants. We simply multiply both the constants and then apply the needed law of exponents. So the 3 times negative 4 will give you a negative 12, while the m cube and the m understood there is a 1 there will be added, so that is m to the power of 4, and we just copy the c there. So that is now the product in number 1. What about number 2? So again, number 2, although there is no a constant before the h to the power of 4, but remember that there is an imaginary 1 in there. So again, multiplying both constants, we have the 5, and since we have h to the 4 and h to the power of 3, we simply add their exponents, h to the 7, then you just copy the v to the 6. And then number 3, we have a negative 5 times 2 fifth, and you know it already. If we will apply the multiplication of fraction, we will come up with negative 5 times 2 will give you a negative 10. So if this is a negative 10, we will be dividing it by 5, so we just come up with a negative 2. Or in other words, we can apply cancellation because the 5 and 5 will give you a quotient of 1. So therefore, we will have a negative 2. Then you just copy all the variables lxc to the 4. Okay, let us proceed to number 4. You have seen here the 2 fifth, and we have also the 3 in here. So remember, the 2 will be multiplied to 3, and then you know it already that there is an imaginary denominator of 1 because every whole number understood that there is a denominator of 1. So 2 times 3 will give you a 6, while 5 times 1 is a 5. So the constant, we have 6 over 5. And then applying the power of product law, we have copy the s. We have to copy the s there, and then we have there s, and then negative 3 plus negative 7 is a negative 10, while the g to the negative 4 times g to the negative 5, which is simply add the negative 4 and the negative 5, then we have a negative 9. And then, as what we have known, an expression with a negative exponents are said to be unsimplified. So we need to simplify them. So a step after this will give you, you just copy the 6 over 5 and the s to the negative 10. Remember that if it is containing a negative exponent, we have to express it into this way. We have a 1 as our numerator, then the s as the base, which is copied, then the power negative will become a positive, and it's already in the denominator. While the g to the negative 9 is still negative, thus we need to copy. We have to have a numerator of 1 and then the g to the positive 9 already. So that's it, the product in number 4. Then the final answer or the final product in number 4, because we need to apply the multiplication of fraction, which is simply multiply 6 times 1 times 1 will give you a product of 6, and then we just copy all the denominators of 5s to the 10 times g to the 9. So that's the final for number 4, and let's proceed to number 5. So number 5, again, the k to the negative 2 and the d to the 3 will be multiplied. Thus, we cannot add their exponents because they are not common. So therefore, we just simply copy k and then the d. Then this time, we have to have k to the power of negative 2 and then d to the power of 3. But you know that the k to the negative 2 will give you a 1 over k squared times the d to the power of 3. And then for this to further simplify, we just simply multiply 1 times d cubed. We have already d cubed over k to the power of 2 is simply k to the power of 2. So therefore, this is our final product in number 5. So let's proceed to number 6. Number 6, we have b to the 4 n to the negative 6 times b to the negative 4. Remember, we can only add the exponents of not the n but the b, the exponents of the b and the negative 4 in here. So we will be having b to the negative no, it's not b to negative 16, but it's b to the 0. This is b to the 0 because we just simply add their exponents and they are common base. So we have to have n to the power of negative 6. So therefore, you know it already that the b to the 0 times n to the negative 6 will give you a final answer of uh, n 1 over n to the 6. So that's it. That's the final answer in number 6. Okay, so let's proceed to the next example. This time, we have already a monomial with binomial, or it could be a monomial with trinomial. So let us have number 1. This is a monomial, okay, multiplied to a binomial. So we just simply apply the distributive property will be applied at this time, but still the loss of exponents that are needed, we still have to apply them. So the negative 4y times the 5y will give you a negative 20y squared, because the negative 4 times the 5 is a negative 20, then y to the power of 2. And then the negative 4y will be multiplied to a negative 2, will be positive 8y. In the number 2, you have seen that the 7 8c to the 6 multiplied to h to the 4. Remember that only h exponents can be added. So we have uh, 7 8 to the 5th, because this is understood, there is a 1 and a 4. And then you just copy the c to the 6, and then plus the 7 8 c to the 6 times 4 h to the power of 5 will give you 28 8 to the 6, and c to the 7. Why c to the 7? Because we have a 6 in here and we have a 1, no, imaginary 1 as our exponent. So this is the final answer in number 2. All exponents of the bases are positive. So let's proceed to number 3. Okay, number 3, negative 7 times 8. So this time we have a monomial and then times a trinomial. So this is a trinomial. Okay, and this is a monomial. Okay, monomial versus trinomial. So the same thing, the same process. We just simply multiply the negative 7 times 8. So it will give you negative 56. Negative 7 times negative 5m will be positive 35m. Well, the negative 7 times the negative 9x to the 5th will be positive 63x to the power of negative 5. And then as you have seen, we have x with a negative exponent, so we need to simplify them. But we have already the shortcut. If it is if it is containing a negative exponent and it's in the numerator, you have to place it in the denominator. So therefore, we have it as our final product. The negative 56 will be written as is. The 35m, because the m has a positive 1. And then the x to the negative 5, it's already in the denominator, but the negative 5 is already positive. So far, our final answer is no longer containing a negative exponent. Let's proceed to number 4. So 6 over 7 is uh, our constant, and a 1/2 as our constant. So therefore, we just simply multiply 6 times 1 and 7 times 2. So it gives you a 6 over 14. Then the v cube times the v, because we still distribute to each uh, term inside the grouping symbol. Thus, we have a v to the power of 4, while the 6 over 7 times v squared is 6 over 7 v to the power of 5. So therefore, this could be final. No, because the 6 over 14 can still be simplified. This can be divided as 6 by 2. It gives you a 3, and then 14 divided by 2, it gives you a 7. So therefore, this is our final product. Well, number 5, we have 2d times the trinomial here. So the 2d times 5d will give you a 10d squared. So if it is a 10d squared, okay, and then 2d times 10f will give you a negative 20 df plus 2d h squared. So let us try reveal if this is correct. So correct. So 10d squared minus 20df plus 2dh squared. So therefore, this is already the final product in number 5. Okay, so this time, let us proceed now to binomial with binomial, because we have in the previous slides, we have only monomial by monomial rather. We have monomial by binomial or with trinomial. This time we have the binomial with binomial. So suppose you are given the 2x minus 5 times 5y minus 2. So considering that we have this these two sets of binomial, the first set and then the second set. So let's proceed. How to find the product if we have to multiply binomial with another binomial? So we have to consider the FOIL method. What is FOIL method? When we say FOIL method, the F stands for first terms. So where are the first terms? So they are the first term. So the 2x is the first term in the first set, while the 5y is the first term in the second set. What is O? So therefore, okay, before going to what is O in the FOIL method, since we are multiplying both first terms, so 2x times 5y is 10xy. And then let's proceed to the O. O refers to the outer terms. So among the two sets, where are the two outer terms? So the two outer terms, as you have seen, the 2 is somewhat outer, and then the 2 is somewhat on the outer part. So if we will be multiplying the 2x times negative 2, then they are the outer terms, then it will give you a negative 4x, because 2x times negative 2 will give you a product of negative 4x. Next is the I. The I refers to the inner terms. So among the two sets, where are the inner terms? So the inner terms are this, the negative 5 and the positive 5y. So they are said to be the inner, because the 2x and the 2 are the outer. So the negative 5 and the 5y are the two inner terms. So what's the product? The product is negative 25y. What about the L? L refers to the last term. So as you have noticed, in every set, we have the first term, then the last term. We have the first term, then we have the last term. So the last terms are the negative 5 and the negative 2. And what is its product? Okay, the product is positive 10. So that's it. So that means that 2x minus 5 times 5y minus 2 will give you a product of 10xy minus 4x minus 25y plus 10. And then before considering this as our final answer, let us try see if there are terms that can be combined. When can we say terms can be combined or similar terms? If they have the same literal factors. So when we say literal factors, the same variable and the same exponent. So we could not add the 10xy and the 25y because they are not similar terms. So we consider that as our final answer. Okay, let's proceed to have another example. So h plus 5 times 2 plus 3m to the power of 2. So where are our first terms? So our first term is the h and the 2. That is why we have the 2h. Followed by the outer terms. So the outer terms are the h and the h and the 3m squared. So therefore we have 3h m squared, because we just simply multiply 3m squared times h. And then the next is the or are the inner terms, the product of the inner terms, which are 5 and 2. So we have a positive 10. And then the last there is the last two terms. So the last two terms are the 5 and the 3m squared. So that's it. It's already 15m squared. So far, there's no similar terms. Thus, this is already our final answer. Okay, so let's proceed to another example. Okay, but before the next example, if you are asked to arrange them into somewhat descending order, so when we say descending order, we should have to start from the highest exponent down to the smallest exponent down to the constant. But well, anyway, if your teacher will ask you to have this as your final answer, then that is still correct. So we have to arrange them according to exponent. 3hm squared plus 15m squared plus 2h plus 10. Okay, let us proceed to the next example. We have the 2x squared plus 5 times x cubed minus 2. So what is its product? So where did we get the 2x to the fifth minus 4x squared plus 5x cubed minus 10? Of course, let us start with the first term. So the first terms are the 2x squared and the x cubed. Remember that the 2 and the 1 will be multiplied, thus we have a 2 in here. So we have the 2, and then the x squared and the x cubed is being added. The exponent can be added, so we have an x to the power of 5. After the first terms, we have the outer terms. So 2 times 2x squared is equal to 4x squared, and then the two inner terms, which are the 5x cubed, and then the last two terms are positive 5 times negative 2 will give you a negative 10. And then again, if you are asked to arrange them into descending order, thus we should have to consider the 2x to the power of 5 plus 5x cubed minus 4x squared minus 10. Guys, I hope you learned something from my video today and looking forward to follow me on my YouTube channel. Do not forget to subscribe and hit the like and share button below. It is my pleasure too if you leave your comment. Again, thank you for watching and God bless you all.